math 210 derivatives based on three different formulas. One we call power function x to the n type, another one is exponential with different bases, e to the x, and then natural log of x with absolute sign and without absolute value sign. The derivative will be same, only you will have issues with the domain. So let me give you two examples. First, you want to take derivative of e to the x squared, so it will follow this rule, but then you have to use the concept of chain rule. Take the derivative of x squared, which is 2x. You are done. Second example, natural log. So I'm using one expression which is not exactly x, more than that, so it's 1 over of that expression, and then take the expression again under derivative. So you are done by the chain rule. Let's give you two more examples. F of x is 5 over x squared plus 2x plus 1 to the 3. So we want to rewrite this as this so that we can apply power rule. Otherwise you could use quotient rule. Since we have only one term, it's better to use power rule. Now take the derivative. Negative 3 goes in front, and then you subtract 1 from this, so you get this one. Now multiply this together, and also the derivative of inside must be taken with the chain rule. That comes out 2x plus 2. Now just simplification part. I factor out this 2 like that, and then more simplified version is this one. Because the exponent is negative 4, put it down in the denominator. Let's look at next one. It's a little more complicated. We can factor out some term from the numerator and denominator separately. So you get 2 factor out here and 3 here. And then distribute the exponent on 2 and 3 and the remaining factors. So you are ready to take derivative now. And you can understand that it should go with the quotient rule. And the format for quotient rule is like this. We write the numerator first, then the denominator side by side. And put a negative, positive sign this just to make the cross multiplication. Now, I'm keeping 2 to the 4 and 3 to the 4 as a constant in front. Now, write your final form like this. So 2 to the 4 is 16 and 3 to the 4 is 81. Now, we multiply this way first, subtract this way, and you can see exactly here. And your denominator must be squared, so you get this. So 16 over 81. So before simplification, we want to see if we can factor out common terms. So 4 you can factor out, x minus 2 with exponent 3 can be factored out, x plus 3 to the 4, you can take x plus 3 to the 3 as a common because you have this one here. So you take all this out. If you take now remaining here is x plus 3 and here is x minus 2. So that we do this way. Now I have rewritten this one, but it is not needed. Let's go to the next step. Now here you see you have x plus 3 minus x minus 2. Open the parenthesis, sign will change. And the next step, now see that x cancelled out. Then go to the next step. Here you get 3 plus 2 is 5. Multiply with 64, that gives you this. So remaining will be x plus 3 to the 3, x minus 2 to the 3, and then x plus 3 to the 8. Now you can cancel some terms here with exponent 3, so that will end up with this, and you're done. This is the most simplified answer. We take more example, number 5. You are given a profit function in terms of quantity Q like this, and the quantity is given in terms of time t. We are looking for rate of change of profit over time t. So that's why dp dt when t is 50. Now see what we do. P is a function of q, so find dp dq, regular derivative. Then you have q is a function of t, find dq dt, regular derivative. Now we want to find dp dt, so you can see when you multiply these two together you get dp dt. This is the concept of chain rule again. And write your answers like this. Now we need to find this one, meaning is t should be replaced by 50. But in my result I see q also, so I need to figure out what is q when t is 50. So that we find here. And then plug your answers back here for dp dt when t is 50. And you get $46,875. So the explanation will be the profit increases by $46,875 per additional year of produce and sell after t equals 50. Number 6. You have a logarithmic function. It's a more example we have. So the first one is very simple. You understand with the chain rule. You write 1 over of the expression, take the derivative again. Simplify further and put it in a nice form. Second one, you have product rule. So I'm writing side by side and their derivatives under. And then we know that we just need to cross multiply, add together, we get our derivative. And you're done. Third one, f of x is 2 e to the x minus x cubed e to the x. Now in this case, you see, this is just one term, so we just might make the derivative and done. But this one has product rule, and I give you the answer, and then in a minute you'll see how it is coming. X to the 3 e to the x, right side by side, take their derivative, cross multiply, add together. That's exactly here. And then further you can simplify, distribute the negative sign, and then factor out e to the x if you want. You are done. Next, example 7 is implicit derivatives. Your functions given in implicit form. So you want to take derivative term by term, and then at the end you replace your x by 1, y by 1. That's the meaning of this notation. So this is regular derivative, as you see. 3 is a constant, leave it there. X square will be 2x because we take derivative with respect to x. 5 you leave, y square will be 2y, and then y should be taken again with derivative as dy dx. The right hand side is constant, so derivative is 0. Now the simplification part, you get 6x minus 10y equals this. Now you can add 10y dy dx, so you get this. Now divide both sides by 10y and you get dy dx. Simplified version is 3x over 5y, and then replace your x by 1 and y by 1 to get this. You are done. Next example I'm taking is a follow-up from number 7. So in this case we are taking the same function in implicit form, same representation, but we want to find the equation of tangent line at 1, 1. So collect result from example 7, that you have dy dx at 1, 1, which is the slope of the tangent line. We got 3 over 5. Now remember the equation of tangent line at the point 1, 1. So your x naught, y naught you collect from this, and m you're given, put it back, simplify, distribute your 3 over 5 here, and then 1 minus 3 over 5 is exactly 2 over 5. You are done. Next example, implicit form again, but with algebraic function and with x and exponential function, power function and exponential function together. So you cannot separate y. Take implicit derivative. First one should go with the product rule, second with the product rule. So first one, product rule, gives you these two terms, second one gives you these two terms, and I carefully keep negative outside within parentheses. Derivative of 15 is 0. And then just open parentheses and then isolate your like terms, factor out dy dx, and then divide both sides by this, you get dy dx. You are done. I want to show you some application in real life investment. So if you have invested $P at R% interest compounded n times a year for t years, then your amount will be with this relation. This you have learned in college algebra or in algebra class. Now we want to do a little more, that if you have n compounded continuously, then is as a limiting case. So this limit of this will convert to exponential form, and then replace that one for this equation, and you get a equals pe to the it. So we'll be using this one. Now look at one example. It says, suppose you have invested 10,000 in a savings account, earning 7.5% per year, compounded continuously for 10 years. How fast is the balance growing? So we just want to see the growth of the balance, so we need to take derivative of this one. So that we do here. And then I just need to plug my values. So collect all information you have. I is R%, which is 7.5%. So 7.5, if you divide by 100, you get this. Remove the percentage sign. T is 10, P is 10,000. So plug all these values here, calculate. So you get this answer, and it is the growth of your investment per year, and you are done. Thanks.